Artificial intelligence has moved beyond answering questions in a chat box. Today, multi-agent systems execute real-world tasks that require autonomous decision-making without direct human supervision. These systems operate with structural amnesia. Structural amnesia is a condition where an artificial intelligence cannot securely recall its own past states, making it impossible to prove which tools it used or who authorized a specific action. Without an immutable record of these steps, deploying AI in public interest sectors like healthcare or finance creates a prohibitive liability for compliance and safety. Regulators cannot audit a system that cannot explain how it reached a conclusion. Until an AI possesses a verifiable identity and a deterministic audit trail, a mathematical guarantee that its history hasn't been altered, it remains a black box that cannot be trusted with critical infrastructure. The Dual Substrate System, or DSS, is a foundational trust layer that sits beneath AI models to make their actions accountable. The first layer is the dynamic processing environment, characterized by real valued flow, tracking quantities like energy and strain. The second layer is a symbolic ledger using p-adic numbers to create an immutable memory for identity, permissions, and lawfulness. The DSS forces the dynamic processing layer to query this ledger for permission before executing any state change. No action is permitted unless the ledger confirms it is lawful and authorized. By separating permanent memory from active processing, the DSS upgrades an AI from a stateless probability engine into a structurally accountable system. First, a user authenticates using a decentralized identifier, or DID. Next, access rights are verified using tamper-evident verifiable credentials, ensuring authorized tool access. Finally, the AI's action is permanently recorded onto the ledger as a cryptographic hash chain, establishing a verified chain of provenance. Traditional security robbers try to filter bad outputs after they happen. The DSS creates a hard cryptographic record at the base level, ensuring deterministic replayability. This allows any action to be perfectly recreated and audited. This mechanic prevents data drift and creates portable trust. Because the records are mathematically verified, that trust can be independently audited across different enterprise ecosystems. The DSS is built in direct alignment with the United Nations Transparency Protocol, establishing international principles for trust and traceability in digital systems. This network diagram illustrates how the system scales. Local AI agents in small clusters, labeled C10, securely aggregate their verifiable data into larger coordinating hubs to maintain global coherence. By leveraging W3C standards for digital identity, the DSS functions as a globally scalable utility. The W3C, or World Wide Web Consortium, is the international organization that develops the standards used to build the web. Adopting these universal protocols removes the governance bottlenecks that currently stall enterprise AI adoption by providing a clear, standard-based path for oversight. The core dual-layer architecture is advanced, and the primary online trust anchors and identity flows are already live. Strategic funding will accomplish the next stage: security hardening, technical documentation, and the execution of external partner integrations. Our vision is to transform AI from an unpredictable generator into an accountable, human-serving participant in our digital ecosystems. The industry solved the problem of autonomous capability. The dual substrate system provides the infrastructure to solve the problem of trust.